Hello everyone, hello bachalo, kaise ho? How are you guys? And welcome Tanmay, Sakti, Yalini, Nelakunit, and everyone out here. Hi Tanmay, how are you guys? Hello Vivek. So welcome. This is Shreyas here, your master teacher for physics at Vedantu, and I'm going live. And today is a very special session, guys, and I'll tell you what is special about today's session in a bit. But before that, let me just quickly introduce myself to all my new friends out here, all the new minions out here. So all the new minions, all the new people out here, come on, introduce yourself, make new friends, talk to each other in the live comment box out there. Yes, make new friends. All right. So guys, I'm Shreyas and I have been teaching for quite some time. I'm a pass out of NIT Nagpur. I graduated almost like a decade back and I have been in teaching for quite some time. And luckily, fortunately, many of my students have cracked the JEE examination. Many of them are in BITS, many of them are in NITs, many of them have cracked KVPY exam, many of them are in ISC, and most of them have even graduated and now probably in some big companies out there. So I really want this channel to help you out to gain a lot of success, to achieve great heights. So we are going to be there with you for making sure that you crack the competitive examinations. Hello everyone. Hi Krishna, Krito, Ankit, Naga, Chandresh. Welcome aboard everyone. And guys, I have updated a very cool status. I'm pretty sure many of you would have seen it. Have you seen it? A very cool meme. It was made by one of our students only. So I just have even given a shout out for that minion out there. So guys, check it out. It's a very cool status on my Instagram handle, Shreyas_Vedantu. And if you make your own memes, do let me know. I can definitely give you a shout out if it is worth it. All right. So before we proceed, I hope you have already liked. Make sure that gray like has turned into blue. Make sure that red subscribe has gone into gray. So confusing. Okay, and I hope you'll share the video with all your friends and recommend this video so that all the interested students out here can definitely gain a lot through this channel. Hello everyone. Hi Manoj. Hi Priyanka. Welcome. Hi Lipika. So yes, come on. I hope you all liked it. Yes, cool. From all of this. All right. Now, where do you get the KVPY mock exam? It's very simple. Just go to KVPY, just Google it. Okay, you'll get this website and you can choose to attempt a mock test for free, no charge. It will give you a fake login screen. You don't have to enter anything. So I thought I need a student ID, but luckily you don't need any kind of ID out here. It's just a fake screen. All right. And you just say sign in and that's it. You're through it and you can attempt the mock test. I'm pretty sure many of you would have attempted it and many of you also have some doubts in it. So let's begin with the solving session, and I have chosen some really cool questions out here today for you guys, and you will be seeing the different approach of me solving these questions. That's very important, and let's begin. So yes, Ankit will be telling you about the mentee schedule, everything next week. Don't worry, the next week's timetable will also be out. Yes, Krishna, it is the same one. Correct. What is that muon? You don't have to worry about it, Dinesh. That's the best part. So, that is what the examiner wants to test. Suddenly, looking at this word, you will be like, what the hell is this muon? What is this muonic atom? I don't know. Guys, that's what they're testing, your presence of mind and whether you get scared and then you lose your cool, your calm, and you become nervous. A person who gets scared looking at this word, that's it, he has lost it. He will not get full marks. He will not get probably cleared in KVPY. So don't get scared by that word. Just look at this question and see how you're going to solve it. A muon of mass 200 times of that of an electron and same charge is bound to the proton. Okay, so it's in the nucleus. Some particle. I don't know what is that particle. It's some crazy particle. Doesn't matter. Okay, so the wavelength of its Balmer series is in the range of, so usually Balmer is in what range? Think about it. Now the Balmer series is going to shift because of that extra mass which is present in the nucleus. I'm calling it a muon. So let's hear that answer in a bit. Don't worry about it. Okay, some of you are saying B, some of you are saying D, some of you are saying A. Clearly there is some confusion. Don't worry guys, I'm going to tell you about this. And Sakti, thank you for the cool memes you sent out there on Instagram. Thank you, and I've shared it. Okay, so before that, let me also tell you a very important thing, guys, for all the 12th standard students, because see guys, it's very important that many of you are probably just prepared for boards, many of you are just prepared for the JEE Mains examination. Some of you are probably half prepared for either of them. Some of you are maybe prepared, but you think that you can do better. If you fall under any of these categories, okay, if you're half prepared or you think you can do better, be it in JEE Mains or be it in boards, then we have made a crash course for both the things together. That is what you should realize. Say, Vedantu is always innovating different stuff depending on the current scenario. See, crash courses are run by many institutes. Probably many institutes also run the CBSE crash course. But we thought, why not give you guys both the benefits? Now, what is the advantage of a crash course? Is because the thing is, you get to revise the entire syllabus, guys. 11th standard as well as 12th standard. It's not just 12th. Understand? Apart from that, it's not a one-way class. There is another tutor. There is another class teacher inside the class who will be solving your doubts. That is very important, because if you have a doubt, imagine even if there are 10 students, okay, even if there are 20 students, doesn't matter. How will your doubts get resolved? Because the teacher might be teaching and suddenly you have a question in your mind. So you just ask the class teacher, the secondary teacher, and he will assist you. That's the best part. And also after the class, there is a separate doubt section where you can ask all your doubts. And in case you miss a class, or let's say you want to revise a topic, you want to see it again, you can always replay it till the end of the exam. It's not like the day crash course ends, that's it. You cannot watch the replay. So you can watch it unlimited number of times. You can ask your doubts and stuff like that. That's very important. Also, guys, what is important is that there are 45. Oops, my Siri has got activated for no reason. Okay, so you got 45 sessions, guys, and 107 sessions for CBSE. That's a lot. And all this is a limited time offer, let me tell you that. And one more thing, we are not charging for the mains crash and CBSE crash separately. The combined crash course price should have been double, but in fact it is just 12,000 rupees. Those of you who know already that the regular crash course fees is around 10,000, so this is just 12,000, but we give you more discount on that and you get it for 20% off. So calculate the price, it's 9,600 rupees. You can use this coupon code or whichever coupon code you like, but my point is, guys, just check it out first. Okay, just check it out and make sure you do not delay the process, because this batch will not be there for a long time. It won't be open for a long time. It will close off very soon. Okay, so if you want to use my coupon code is SHCC21. So let's see what the answer should be for this particular question. Okay, so the link of the class is put up in the description box below, Ankit, so you can check it out and all the details are mentioned. And trust me, the teachers are really good. I know them personally. Okay, so they are really good and they have been training kids for a long time. Now, the thing is, there are different kinds of series when electrons transit from different orbits: Lyman, Balmer, Paschen, Brackett, etc. We are talking about Balmer, and Balmer is usually in this visible spectrum, correct? Now think about it. What happens when you have a mass which is 200 times that of the electron inside the nucleus? Now it so happens that the energy of an atom, okay, in ground state or any other state, remember it was proportional to z square by n square and stuff like that. There are a lot of constants, but apart from that, it's being proportional to 1 by n square. It is also proportional to the mass, but this m is the mass of, think about it, what is this? This is the mass of, what is this? A muon of mass 200 times that of an electron, and same charge is bound to the proton. Now, what do you mean by it is bound to the proton? Is it inside the nucleus or is it orbiting the atom? The answer is it is orbiting the atom. Bound ka matlab, it's not exactly inside, It's close to the nucleus. It is orbiting that nucleus just like an electron, but this is the mass of the electron. Understand that. But instead of electron, what do you have over here? You have the new particle, which is muon. Understand. Because of that muon, what will happen? The mass will become 200 times. Correct, guys? So this mass will become how many times? 200 times. If this mass becomes 200 times, this energy should also become 200 times. Now, if this energy becomes 200 times, what will happen? All the series will also have energies which are 200 times more. All this Lyman, Balmer, Paschen, etc. will have energies which are 200 times more than their original energies. If energies are more, then if you look at this electromagnetic spectrum, all right, you have gamma rays, X-rays, ultraviolet, visible, infrared, microwaves, radio waves. So you can see on this side the frequency increases, over there the frequency decreases. If frequency increases, what happens to the energy? It's clearly mentioned, the energy also increases. So from visible spectrum, the energy increases 200 times and it will go to somewhere in the X-ray range. That's what will happen. I hope this is clear. I hope this is clear. Is that understood now? Is that understood? All the minions, have you understood? So I'll repeat. So this muon is just like an electron, hypothetical particle, which has 200 times more mass, and energy is proportional to mass. Remember that. Okay, this formula. So mass increases 200 times, energy also increases 200 times. This entire graph also shift by 200 times. So if all the energies also increase by 200 times, so visible spectrum will also shift to X-ray spectrum, guys. I hope this is clear. Is that clear, guys? So that is what has happened. That is what has happened. Okay, cool. So let's go to the next question. So guys, do not get scared. No, case one, they don't have more than one. Okay, so they don't have more than one. Don't worry about it. Okay, so let's go ahead. Okay, just one sec. My light just got stuck in my microphone wire. Okay, so answer is X-rays. Let's go to the next question. Very interesting question out here. So let's see. Okay, so there is a spherical rigid ball and it is released, okay, from rest, and it starts rolling, okay, on an inclined plane from height 7 meters as shown, okay. It hits the block after it comes down. So it rolls like this, comes down and it hits the block, okay. It transfers some momentum, obviously. If the mass of the ball and the block is same, okay, and it is m, then what is the speed of the block after the collision? What is it? Approximately equal to 6, 8, 10 or 12. So many of you are saying C. So let's try and figure this out. Guys, this is such a beautiful problem. I'll tell you what happens. What happens in this question is, see, it starts from rest over here, correct? As soon as it comes down, please understand, it not only has velocity, but it also has angular velocity, guys. Yes, it is rolling. Did you not read it carefully? It has the word mentioned, rolling. So guys, it's not only going to have velocity, but also angular velocity. So think about it, that gravitational potential energy, mgh, has got converted into kinetic energy of translation as well as rotation. So it will be half m v square plus half I omega square. Isn't that correct? So this is rotation. This is translational. Now MMM goes from everywhere, so I will get v square by 2. Okay. Moment of inertia, think about it, is 2 by 5 mr square because it's a spherical rigid ball. So 2 by 5, that m would have gone from everywhere, so I've just skipped that m. And omega is nothing but velocity by radius whole square. Why is that so? Remember, because it is rolling, v is equal to omega r. V is omega because it is rolling, that's it. So now think about it, what will happen in the next step? GH is equal to r square gone. So this is 1 by 2 plus 2 by 5. So it will become 5v square. Take LCM plus, correct? And I hope this is fine. Yeah, and this will be 4. I think I missed one 2 out there. Oh, okay, there was one more 2. Yes, my bad, guys, sorry. There was one 2 out there. So half I omega square, that 2 by 5 is from moment of inertia. So one more 2 was there. So I just need to multiply by 5 then. And by the way, this 2 and this 2 also gets cancelled. That's very good. So this will become 5v square, correct, plus 2v square divided by 5 into 2, the LCM of that. Okay, so this is going to become 7v square by 10gh. Okay, cool. So now the next step will be just finding the velocity. That velocity will be 10gh. Okay, and 7 will come downstairs and the root of that. Now just substitute the values. What is the height? Height is 7 meters. So 2 into 10 into 7 divided by 7. 10 gh, my bad. 10 into 7 by 7, so 10 is 100, so the root of that is just 10 meters per second. But that's the velocity of the sphere, not the block. Now the question is, find the velocity of the block, not the velocity of the sphere. Now guys, think about it. I have given you one property. If there are two masses, both are m, if one has some velocity, after the collision, what happens? The velocity gets transferred. This is a very important property, very important for elastic collisions only. Remember this. So guys, whatever velocity was there with the ball will get transferred to the block because it is elastic collision and the masses are equal. So this will be also the velocity of the block after the collision. So that's the answer. I hope this is clear, guys. Yo, is that understood? Yes, correct. Cool. Yes, the answer is 10 meters per second. Very good, very good. So the answer, some of you before we started this problem said it was 10. So by the way, the answer is 12. Okay. So the options were 6, 8, 10 and 12. And yes, so I saw some discussion going out there. Oh, will the energy be not conserved? No, Joanne, energy will be conserved. I'll tell you why. Because, you know, think about it. Number one, it's an elastic collision. Masses are same. So this sphere would have some kinetic and energy. So all that energy will be transferred to the block, okay, and the sphere will stop. So, you know, the energy will be conserved, but the sphere will still have spin. Understand that? Translation will go away, but spin will remain. So that kind of a question can also come. So the spin energy will remain because that spin cannot be transferred. Yes, I understood, Johan, what you are trying to say, that what will happen to the rotational kinetic energy. So the rotational kinetic energy will still remain. Okay, cool. Good evening, VK, join in. All right, so let's begin with the next question. And here it is. So a train is moving slowly, very good question, 2 meters per second. And there is a man whose height is 1.5 meters. He alights from the train such that his feet are fixed on the ground after he jumps. So he jumps out of the train, his feet get fixed, taking him to be a rigid body. The instantaneous angular velocity is 1.5, 2, 2.5, 3. All options are given. So let's try to solve this question. It's a very good question. Now, let's try to visualize this. Let's bring in Pandu. So here is our Pandu, and he is going with the train with a speed of 2 meters per second. All the points are moving with 2 meters per second, and then when he jumps and falls onto the platform, okay, then what happens? Oops, yes, look at that, his feet are fixed. So his feet are fixed. Why? Because of the friction out there, his feet get trapped. He is not able to move his feet, but because of the momentum, because of the inertia, he will fall ahead like this, and that's why there will be an angular velocity. Do you see that? So there was translation, now there is angular velocity, and that's what we need to figure out. Now this situation is similar to, there is a rod, okay, there is a rod. Think of Pandu like a rod. Poor Pandu, we have made him like a rod, and it is translating with 2 meters per second, and then suddenly somebody holds the rod at the bottom and you have to find what is omega. That's what the question has boiled down to. So now it's simple, guys. If you look at this point over here, this point, okay, about this point you can conserve angular momentum. Yes, you can conserve the angular momentum of that system Because at that point there is a sudden impulse. So when you hold that point, you can conserve the angular momentum, because no torque will come about that point when you hold it over there, or when you measure the angular momentum over there. So that's the whole point about this. So what will happen is that the angular momentum initially should be angular momentum finally. What is the initial angular momentum of the rod? Initially, think of the rod like a point mass, and the point mass is m, and it is translating with 2 meters per second at a distance of L by 2. You know how to find the angular momentum of a point mass, m r v. So m is m, r is L by 2, v is v, or let's say it is 2 meters per second, is equal to, when his feet are fixed, it is like a purely rotating body. For a purely rotating body, what is the angular momentum, guys? It's just I omega. So I omega, that's the formula. So I into omega, that's it. So now 2 gets cancelled. ML is equal to, what is the moment of inertia of a rod about the end? It is ml square by 3. Be careful, not by 12. ml square by 12 is at the center. At the end it is by 3, and into omega. ml gone, so you will be left with omega is equal to 3 by L. Oh, wait a minute, L is also given. How much is the length? It's given 1.5 meters. So 3 divided by 1.5. Obviously, the answer is 2 radians per second. What a beautiful problem. Did you guys get it? Yes, poor Pandu had to become a rod. Look at the sacrifices Pandu is doing for all of us. So guys, you should also sacrifice a lot of things if you want to crack JEE, if you want to crack KVPY, if you want to crack all the competitive exams, guys. Alright. So Ankit, which part you did not understand? See, please tell me which part you did not understand. So Pandu was that rod who was translating, then he became a rod which is rotating with omega. Which part you did not understand? Please let me know. Yeah? Which part? Which part? Which part? Did you? Come on, quickly, before I go to the next question. Quickly, Ankit. Omega. Angular momentum of a rigid body is I omega. Do you know this formula? Just like momentum is mass into velocity, angular momentum is I into omega. So for this body, what is the angular momentum? I into omega. That's it. That's all. So earlier the angular momentum, so this is same as a point mass traveling with velocity v at a distance of L by 2. So what is the angular momentum about the same point? It will be mrv. And what is the angular momentum finally? I omega. So equate it and now you'll get it. Is that now clear, Ankit? Is that fine? Okay, very good, excellent. Chalo, so that is the answer, and let's get going to the next question. Don't get scared by this length of the question. Don't worry about the options also, guys. You have to get the answer. Options are just there to probably confuse you. Never worry about the options and never worry about the size of the question. So there is a certain body. It has a radius and some temperature, and it is at some distance from the earth. Astronomical unit is the distance between earth and the sun. Remember that. Okay. And RS and TS are the temperatures of sun and the radius of the sun. Okay. Take both the sun and the star to be ideal black bodies. Excellent. The ratio of the power received on the earth from the body as compared to that from the sun. So actually the word here that should have been used is not exactly power. It should have been probably intensity. You can treat this word like intensity and not exactly power. So let's try and solve this particular question. So guys, think about it. I'll tell you what is exactly happening in this question. See, what if you have a body, okay, and it is radiating energy, okay, like this in all the directions, and let's say the radius is r and the temperature is T. Then what happens is, if you are at some distance small r, at this point the intensity, okay, the intensity of that radiation, the black body is emitting some radiation, Okay, that radiation will go everywhere in all the directions throughout that green imaginary sphere. So that intensity will be how much energy was generated or radiated upon the total area of that imaginary sphere, which is 4 pi r square. Why 4 pi r square? Because it's an imaginary sphere. Imagine that radiation will go everywhere, north, east, west, south, up, down, etc. So that energy per unit area is called as intensity. How intense it is? Watts per meter square. So this will be energy radiated per unit time. So this is actually power radiated, think of it that way. But some people also write it as energy radiated per unit time. So they put a dot over there just to signify it is per unit time. So it's up to you how you want to write it down. Is that clear? Is that clear, everyone, till this point? Is that clear? Yes. I hope everybody has understood till this point. Intensity is energy radiated by the total area. So that's the intensity at that point. Now think about it by Stephen's law. Okay. Now you would have heard about Stephen's law. Energy radiated is E sigma A temperature raised to 4. The energy radiated per unit time is E sigma A T raised to 4. E is 1 because it's a black body. Sigma is a constant. A is the area of the body which is radiating. What is the area of the body which is radiating? That is the surface area of this sphere. That means it should be 4 pi capital R square. Understand, this R is not the same as this R. Please get it. This body is radiating from the surface. So the surface area of the body which is actually radiating into T raised to 4. Okay. So therefore the intensity will be this whole value, which is sigma 4 pi R square T raised to 4 divided by this value, which is nothing but 4 pi small r square. So 4 pi goes, and you will have sigma, you will have r square T raised to 4 divided by small r square, guys. Is that understood? Is that understood, everyone? Okay, so this is the intensity. Why we did this? Because we want to find the ratio of the intensity received from two different objects. Now I'll erase everything else which is not required. Okay, I'll just keep the necessary stuff. So this is the formula for intensity, and let me also erase this. Now just think about it. Just think about it. This is our Earth. It is receiving some radiation from the sun and some radiation from that body. These distances are different. For the sun, the distance is 1 astronomical unit. For that body, what is that distance? Where is it? It is 2 into 10 to the power 10 astronomical unit. Is that correct? The temperature of the sun is Ts. The temperature of that body, random body, is 2 Ts. The surface, the radius of the sun is Rs. The radius of that body is 50 Rs. Now just you have to find the ratio, guys. You just have to find the ratio. So intensity of that body upon intensity of that sun. What will it be? Think, sigma is a constant, guys. So R divided R square by R square, first term. It will be R of that body divided by R of that sun whole square, correct? Temperature by temperature whole raised to 4. So temperature of that body divided by temperature of that sun whole square, and inversely proportional to R square. So distance of that body, no, distance of that sun divided by distance of that body whole square, because it is inversely proportional. So now just you can forget this. There is no need of this. I hope you understood how I actually arrived at this particular situation. I hope this is clear. Yes. So this is from heat transfer, radiation. Now, what is the radius of body upon radius of sun? Look at this, radius of body upon radius of sun. It's nothing but 50, guys. So 50 square into temperature of body upon temperature of sun. Temperature of body upon temperature of sun, 2. So 2 square into distance of the sun upon distance of body. So 1 divided by that square. So it will be 1 divided by 2 into 10 to the power 10 whole square. Come on. 2 square will go. Oh, this was whole raised to 4, my bad. So sorry guys, this was not 2 square, this was temperature raised to 4. I probably missed that square out there. Cool. So 2 raised to 4. So this will become nothing but 50 into 50 into 2 into 2. The whole thing divided by the 2 square and 2 square have got cancelled. So out of the 2 raised to 4, 2 square has got cancelled and this will become 10 raised to 20. Now think about it, 50 into 2, 100, 50 into 2, 100. So this will become 100 into 100, which is 10 to the power 4, and 10 to the power 20 will go up. So it will become 10 to the power minus 20. So this will become 10 to the power minus 16. Yes, so that's how you get the answer as 10 to the power minus 16. Is that clear? So this will be a good question, but a question which will definitely help you gain a lot of marks. Cool? Ankit, I have not yet completed this chapter in the regular sessions, but I'll be covering it up. But I just told you so that you have some idea. And guys, I'm coming up with a very good surprise for all of you next week. You know what is that surprise? Entire 11th standard formulas in one lecture and entire 12th standard formulas in one lecture. Don't you think, guys, that will be a very cool thing to do? All the 11th standard formulas, all the 12th standard formulas in one lecture each. Big revision for your KVPY. And don't worry, I will be talking about, yes, why intensity? Because you know the energy which will be falling on that object, which is the earth, will be obviously dependent on the intensity. Not all that energy will be captured, only a small fraction will be captured by earth. So that's why energy per unit time. Yes, they asked power, but understand what they have actually asked is intensity. I know they asked power, but think about it, the power which will be captured by the earth, okay, the power which will be captured by the earth will be proportional to the intensity, because no matter how far you go or how close you come, the size of the earth will remain the same. So what matters is energy per unit area, because when you multiply it with the area of the earth, that will eventually be a constant, so it won't matter so much. That's why. So Ankit, for JEE, it will be done before the JEE examination. And Ankit, the reason why I'm doing this special session is because there are certain topics like waves, like heat transfer, etc., which are still yet to be completed in the next coming few weeks, and I'll be doing that. And remember, I promise, I'll never be hurrying through stuff. Okay, I'll never be like, okay, I have to complete so much, I'll do it within 1 second. I'll be doing it in 1 hour. So for your KVPY exam, that's a special session. Yes. Obviously, that formulas will be useful for JEE as well. I mean, it's not like, oh, this formula will be only useful in KVPY, you cannot use it for JEE. Believe me, that session, you can use it even for JEE preparation. Okay, so 10 to the power minus 16 was the answer. So come on, think about it. No problem, Rakshita. You can watch the replays of all the sessions on JEE Enthuse. Do check it out. All the lectures which I have conducted, everything has been conducted properly from application point of view, so that you guys get a lot of marks. Thank you, Manav, so much. Okay, come on, let's move on to the next question. What do you guys think for the next question? This is also a very interesting question. I'll tell you how to solve this. So I'll just tell you the gist of this entire thing. There is a rod, you're applying some force and the voltage has been measured. How will the voltage change with respect to the strain? How will that voltage and strain be related? Manav, I have made a video on how to take care of 11th standard if you have ruined it. In fact, it's there on this channel only. Just check it out. Wasted 11th standard. What should be the strategy? Please check it out in the past videos after the class. So, first of all, understand when you apply force, what will happen? The length will change. If length changes, area will become less. And because of that, resistance will change. And if resistance changes, what will happen? Voltage will also change. Are you guys understanding it? So voltage is dependent on the force very indirectly, and that's what we are going to try and do. So think about it. You know, resistance. Okay, resistance is rho L divided by area. Okay, but remember, volume is constant. So volume is, think about it, volume is area into length, area of cross section into length. So what will be area? It will be volume divided by length. So volume divided by length. So it will become rho L square by V. this is volume. Please understand that. Okay. Now think about it. If I ask you, what is delta R by R? Delta R by R will be 2 times delta L by L. Isn't that right? Using the formula for errors, you will get this. Yes. So formula for errors, relative change in the resistance will be dependent on the relative change in the length. Volume is constant, rho is also a constant. Cool. So that's what I got from here. Now what should be my next step? Think about it. This delta L by L is nothing but strain. So it will be 2 times epsilon. So therefore delta R will be R2 into epsilon. Epsilon is the strain, remember that, because all the graphs have strain on the x-axis. So guys, think about it. The potential difference, this is potential difference by Ohm's law, is I into resistance. I into resistance. Think about it. So what will be the value of resistance? It will be some original value of resistance plus some delta R. Isn't that right? Original resistance plus some delta R. So guys, think about it. It will be I into R naught plus delta R is 2RE. So guys, don't you see that the potential difference is a linear function of the strain? In fact, it's an equation of straight line with some constant over here. So guys, it should start with some value and it should have a straight line like appearance. So that's why the correct answer should be option A. I hope this is clear. I hope this is clear. Everybody has understood this? So lot of things in one question. There is errors, there is resistance, there is solids and elasticity, and obviously basic common sense like, volume is conserved. What a brilliant question. I hope this is fine. Okay, cool. Let's get going to the next question. And here it comes. A photon falls through a height of 1 kilometer through the Earth's gravitational field. We have to calculate what is the change in the frequency if the mass is taken to be h nu by c square and the fractional change in the frequency v is close to how much? Let's try and do this. Kirito, more than me scolding them, it will be a problem for them only, because and I agree with you, Princey and others. If you miss the live classes, there is no fun in just watching the replays. Number one. Number two, guys, I'm doing a lot of hard work. At the back end, a lot of things go on. It's not just the teachers. There is a whole back end team which makes all these slides, which collects all these questions. There is a channel manager. So many things who are trying to see what will be the best thing for you guys. And so you have to take full advantage of all these things which we are doing it for free, guys. And like I said, I'll be teaching on YouTube for free always. All right. So that's one thing. Yes, Ankit, I do know Arvind Arora sir. He's a very, very great teacher and very, very great YouTuber too. Yes. Okay. So let's see how to solve this question. It's a very interesting question. So what happens, guys, is that there is a mass over here, which is a photon, and it falls down, okay, by certain height. So it was at rest and it comes down, and what happens is basically you have to conserve energy. So it has some potential energy, and here it has some frequency, let's say mu1, and here it has some frequency mu2. Mu1 and mu2 are the frequencies. So mgh plus h mu will be, understand, h mu2. So potential energy plus initial photon energy will be h mu2. Remember, do not forget, photons have an energy of hf. H is the Planck's constant. Oh, but let's not get confused between this h and Planck's constant. So I'll use a different symbol. If height is capital H, then this should be also capital H. Else, a lot of people ended up cancelling this h, and this h, and they'll get a completely different and a very strange answer, guys. I hope this is clear. Okay, so do not do that. A very happy birthday to you, Daniel P. Very happy birthday. Congratulations, and I hope you do really, really well, Daniel. Hello, Shreya, welcome. And now let's try and solve this. So mu2 minus mu1 will be mgh divided by small h. But We do not want this. We want the fractional change in the frequency. Okay. So guys, fractional change means mu2 minus mu1 divided by mu1. Change upon original is the fractional change. So it will be nothing but, okay, think about it, mgh, this capital H, divided by small h. What is this mu1? Okay, it's not that difficult to see because the mass is given by this. So guys, can I not say that mass is nothing but h mu 1 by c square? So just use this over here. Things will be a little bit simple. So let's do that. M is h. Okay, but I don't want, hold on. I do not want mu1. Okay, one second guys. One second. Let me just think about it. I do not want mu1. So okay, I can do this. I just substitute this as h mu1, okay, by c square, and there will be gh and there will be small h. Now I take this mu1 over here, so I'll get whatever I want. So I'll get mu2 minus mu1 by mu1 will be h cancels, and I'll get gh by c square. Now this looks fine to me. So what is the value of g? G's value is 10. What is the value of h? H is 1 kilometer, so 10 to the power 3 meters. C square is 3 into 10 to the power 8 whole square. So this will become 10 raised to 4, and 3 square is 9. 10 to the power 8 whole square is 10 to the power 16. When it goes up, it will become 10 to the power minus 16. So this will become 1 by 9, and this will become 10 to the power minus 12. 1 by 9 is approximately 1 by 10. So this will approximately be equal to 10 to the power minus 13. That should be the answer. I hope this is clear. This is approximately 10 to the power minus 13. Is that understood, guys? Everyone? Cool? Syed, that's the standard value. Speed of light is 3 into 10 to the power 8 meters per second. Okay? I hope this is clear. Cool. Chalo, let's get going to the next one. So the main thing over there was to make use of this data. If you do not make use of this data, then things will be wrong. Okay. Now, again, a very interesting question. There is unpolarized red light. It is incident on the surface of a lake at some angle. There is an observer seeing that light which is getting reflected from the water surface through a polarizer. And he notices that on rotating that polarizer, the intensity of light drops to 0 at a certain orientation. Interesting. The red light is replaced by some blue light. Then the new angle is theta b. So question is, find the relationship between them. Very interesting question. So what should be the relationship? Now guys, let me tell you an interesting fact. Whenever there is some unpolarized light which gets reflected from a surface, then understand at a particular angle where the tan theta is equal to mu, okay, when the tan theta is equal to mu, then understand this reflected light and this refracted light are perpendicular to each other. Not just that, this reflected light is polarized in nature. Very important theory. This is called as Brewster's law. I'm giving it to you straight away. Remember it. This is unpolarized light. This is unpolarized light incident at angle theta. If tan theta is equal to u, then the reflected light and the refracted rays are perpendicular and the reflected light is polarized. This is what you should remember. Yes, this is called as the Brewster's law. You should remember this. B-R-E-W-S-T-E-R, Brewster's law. Cool. So now understand what happens in this question. It's given that theta is that angle at which you do not see anything. The intensity drops to 0. So there is a person here, he's seeing the reflected light and he does not see anything at a particular angle. When will he not see anything? When, understand, the polarization plane is perpendicular to the polarizer plane which is holding. If they are perpendicular, understand that that polarized light cannot pass through the polarizer if they are perpendicular. So, that's what it means. So, theta is the angle. So, let's use this. Think about it. If I compare mu for red and if I compare mu for violet or blue, who has bigger mu? Is it red or is it blue? Come on guys, who has a bigger mu? It's the violet, because violet deviates the most, red deviates the least. If that is the case, think about it. Tan of theta for red should be less than tan of theta for blue using this Brewster's law. That means theta r must be less than theta of blue. Number 1. And also do not forget, mu is always more than 1. If mu is always more than 1, tan should be always more than 1. That means theta should be more than 45 degrees. So all of this should be definitely more than 45 degrees. This is the correct answer. I hope this is clear. So remember, in a prism, when you pass light, okay, then the red light, okay, the red light deviates the least, and the blue light, okay, so the blue light deviates the most. This is what you should remember. So it goes ulta, it goes upside down. Violet, indigo, blue, green, yellow, orange, red. This diagram you should remember. Yes, NCERT should be done, Ankit, very important. Cool, let's get going. So this is the correct answer, just like we thought about. What about this question, guys? What about this? How about this? A neutral spherical copper particle has a radius of so and so. It gets charged by applying voltage, 1 electron at a time. How will the graph of the charge versus the applied voltage look like? So guys, this is very simple question. I'll tell you why. When you keep on increasing the voltage on the sphere, more and more charges keep getting added. But understand, charge is quantized. Electron charge will flow one at a time. One electron will keep getting added. So the charge will build up in quantized manner. So the graph has to be a step function. It cannot be a smooth curve because charge is always quantized. So hence the correct answer is option A. This is very straightforward but very conceptual. So Syed, which question? I am guessing you are talking about the previous question. The previous question is from optics and wave optics as such. Okay? So you can talk about wave optics. It's from that particular chapter. Okay? Some people also discuss it in EM waves, by the way. Cool. So now this question, I'm going to solve it in such a beautiful manner, guys. You will be amazed. And after this lecture, please check out on websites or wherever on Google, if you want to, that is, how people have solved this question. And you will be surprised to see how different my method is. Okay. So the question is, there is a charge which is distributed on a ring and the linear charge density is this and it is in a xy plane. Okay. What is the work done by the force in displacing a charge q from the center of the ring to infinity? And there are some options given. Let's try and solve this question. First of all, let's try and understand what is exactly happening. So this is our ring. Okay. This is the radius of the ring r. Okay. And what is given? That if this is theta, here the lambda, what is lambda? It is in coulombs per meter, is a function. It's a function. What kind of function it is? It is q sine square theta divided by pi r. Okay, so that's the function. It changes. If you change theta, the charge per unit length is also different. Every point has a different charge density. So the total charge on the ring is unknown. That is the problem. That is our problem. So let's see, how do we solve this now? Now, That's one thing. Okay, I don't know the final charge on it. One more thing, there is another charge over here, capital Q. Yes, the work done in displacing the charge capital Q, which is taken from here till infinity. How much work is done? Okay, so to calculate work done, what do we need? Potential energy. At infinity, what is the potential energy? Think about it. At infinity, what is the potential energy? It is 0. At the center, okay, so at the center, what will be the potential energy? Because every charge on the ring is at the same distance, correct? It's at the same distance. It will be just 1 upon 4 pi epsilon naught q into total q on that ring. Okay, so total q on that ring divided by r. I hope this is clear. Everybody has understood this? So 1 upon 4 pi epsilon naught q by r. This q is of the ring, the total charge on the ring. So now think about it. The work done will be just to change the potential energy. So final and initial, just you subtract this and you will get it as 1 upon 4 pi epsilon naught q ring by r. Now there is a problem. I do not know this value. So to find the work done, I need to know this. I do not know how much is that. So let's figure this out. How much is the charge on the ring? So the logic is very simple. The total charge on that ring, think about it. For finding that out, I'll first figure out what is the average value of charge per unit length. This is the symbol for average. It will be Q is a constant, pi and R are also constants. It will be the average of sine square theta. The average charge per unit length on that ring is the average of this entire thing, but since Q and pi R are constants, so they have been spared and you just have to find the average of sine square theta, guys. What is the average value of sine square theta? Don't you know it? It's half. It's always half, you should remember it. So it will be Q pi R by 2. It's half. Now this is the average charge density per unit length. So guys, what is the total charge on the ring? It will be the average charge density into the circumference. It is into the circumference. So what is the average charge density? It is nothing but Q by pi R2. Circumference 2 pi R. 2 pi are gone. It will just become Q. Oh, interesting. So you just put that over here. That's it. That's the answer. 1 upon 4 pi epsilon naught Q by R. That's the answer, guys. Interesting. Why did I find the average? Because I wanted to find what is the total charge on the ring. And the average of any quantity will be the average of the quantities on which it is dependent on. And on the right hand side, since these were the quantities and out of them some were constants, so you'll just take it out and you'll just find the average of the variable. I hope that's clear. Cool. What an interesting method this is. So that's the answer, guys. I hope, Rajwal, that's clear. So in what type of problems? Problems like these, or problems where you have to find average, or something is a function of something and you know that by just finding the average you can find the entire thing's physical quantity. Like here charge density was variable, so I wanted to find a total charge. So by just finding the average charge density, I have found out, you know, the total charge. So things like that, you can use it in acceleration, velocity, so many other places. So I'll be taking up a lot of questions like this. Stay tuned, because a lot of problems and tricks which I'm going to teach you. Okay, cool. Let's get going to the next question. Now this looks like a scary question, but trust me, it is not. First read it. There are 4 electrons. And each of some mass in 1D box of size L. Assume that the electrons are interacting and obey some crazy principle. They are just to scare you guys, don't get scared. And described by standing de Broglie waves. So there is a standing wave also in the box. Define alpha as this. If mu naught is the ground state energy, then. This is just a scary looking question, trust me. It all that is mentioned, or all that is to be taken care of is, just imagine a 1D box. Okay, just imagine a 1D box like this of certain length L, and there is a standing wave in it. Yes, something like this. There is a standing wave. There are n such loops of that standing wave, and that lambda out here, this lambda that you see, okay, this lambda, that lambda is the de Broglie's wavelength. So it is just nothing but h divided by p, where p is the momentum. That is the meaning of that question. Cool. And we know that in standing waves, this length, if it is L, all right, then understand the length of that is always n times lambda by 2. There will be, see, each loop is lambda by 2. If this is lambda by 2. There are n such loops, so n times lambda by 2 is the length. Cool. Now what should be done next? Oh, lambda is h by p. Great. So it will be n times h by 2p. Cool. And from that I will get p is equal to nh by 2l. And from that I will get the kinetic energy, guys. The kinetic energy, remember, is p square by 2m. So p square will be nothing but n square h square by 4l square, and that 2m will also come over here. Now out of that, some things are constant. H square, 4 2s are 8, l square and m. So they are all constant, and that is given to be alpha. Cool. Use that, so it will become alpha. Only n square will remain outside. So that is the kinetic energy. Great. Now think, in the ground state, what will be the energy? Ground means n should be 1, so it will be just alpha. In the first excited state, that means n should be 2, 2 square is 4, so it will be 4 alpha. In the second excited state, it will be, n will be 3, so 3 square is 9, so it will be 9 alpha. Ground state energy is how much? U naught. Ground state energy is U naught, so this is U naught plus 3 alpha, and this is nothing but U naught plus 8 alpha. We got the answer. We got the answer. That's it. Yes, you should read waves for JEE as well. Hello Geeta. Hi Saran. All right, so that's the answer, guys. Look at it. The total energy of the second excited state is mu naught plus 8 alpha. That's it. If you solve it systematically, if you know all the theory, you will get it. You should know the formulas. That's it. Don't get scared. Cool, cool, cool. Athar, we do not have those kind of questions where Pauli's exclusion principle is not obeyed. We have to assume that it will be obeyed. Okay? And if it does not obey, then things will go haywire. Things may not exist the way they are, Athar. Okay? And don't worry about such things. It is just to confuse you, and you should not get confused by that. That's all. Cool. So it's not just from electromagnetic waves, it's from waves, it's from modern physics. So many chapters were combined over here. So Syed, why don't you do one thing? Why don't you ping me on Instagram? I'll definitely help you out. My Instagram handle is Shreyas_Vedantu. Okay? On Instagram, just ping me. I'll definitely help you out. How about this question? Now, let me tell you, how many of you have that OCD? Okay? Because this question is based on OCD. I'll tell you what OCD is in a bit. There is a rope of length L, uniform density, and it is hanging from the ceiling. A wave is generated close to the end, and it travels up through the rope. Which of the following is the correct option? So guys, think about it. This question was meant to be solved in a very easy manner. There is this rope which itself has mass, and you are generating a small pulse like thing over here. Okay, small pulse like this, and this pulse will travel like this with speed v, and the tension, okay, the tension will depend on where you are. The tension in that rope will depend, because if you are below, the tension is less. As you go up, you have to pull more weight, so tension will increase. Think about it. The topmost point has to pull the entire rope. The bottommost point has to pull nothing. So as you go up, tension increases, obviously. And remember, velocity of a wave, okay, the velocity of a wave is root of tension divided by mass per unit length. Velocity of a transverse wave. Okay, remember this formula. Now think about it. As x changes, won't tension increase? Think about it. Won't tension increase? So tension will be constant along the length of the rope. Obviously this is wrong. C option gets wrong because it's mentioned it is constant. Wrong. Speed of the pulse will be constant. That is also wrong because tension is going to change. So how can the speed of the pulse be constant? So option D is wrong. Speed of the pulse will decrease as it moves up. Guys, as it goes up, tension increases, speed increases. So how will it decrease? No, that is also wrong. So the only correct option should be B. Now a lot of people think, oh, what if this is also wrong? Some people end up trying to solve this option also in the exam because they have OCD. That is basically nothing but obsessive compulsive disorder. They don't get satisfied. They want to try. They want to check whether that is correct. They have some weird kind of logic in their mind. Hardik, I have conducted essay mock paper on Monday. Please watch the replay. I have conducted that mock test discussion. So guys, do not have that OCD. Some people have it. Like, I should keep my pen in this position only. Or I should enter the room this way only. Or I should drink this water only at this time or after this time or before this time, or else something like this will happen. Don't you have things like this? Yeah. So guys, that creates a lot of wastage of time in the actual examination. So do not give in so easily. You have to get over this. All the top rankers do not have OCD. They will quickly think, okay, A, C, D eliminated, gone. B, correct. I'm not going to bother. That's the headache of the examiner to make sure that this option is correct. It's not your headache. It's the headache of the examiner. So why bother? You have eliminated. You have got it through logic. That's it. Logic is correct. Answer should be correct. Move on. Remember this. Okay. Cool. Let's get going to the next question. All right. So let's have a look. Let's have a look at this question. Very interesting question. Now, I'll tell you what is going to happen in this question. Forget all this data. I'll just explain. See, there is some container, there is some height, liquid is going to come out. Don't you think that liquid will slowly start decreasing? If the liquid starts reducing, speed will change. The speed at which the liquid will ooze out of that small hole based on Bernoulli and Torricelli, guys. Hydrodynamics question this is. And because the speed will change, this liquid will not fall at the same point. It will slowly start coming closer and closer to the container. Now, a person has to move this container with a velocity so that the water always falls on that container. And that's the question, guys. What is the speed of the bucket so that the water exactly falls on that bucket? It should not fall outside. So you have to continuously move it. I hope you guys understood this. What an interesting question. All right. Now, let's try and solve this. First of all, what is the formula for range? The formula for range, I have given this to you. 2 root height from the top where the hole is drilled, which is small h in this case, into the height from the bottom where the hole is. 2 root hh. Think about it. This was the formula. I had given this to you. Okay, cool. So if you don't remember this, please go back to our previous sessions. We have discussed this. Yes, 2 root hh. I think someone also said that. Cool. Now, what will be dx by dt? Now, 2 and capital H are constants. So 2 root h is a constant. So it will be derivative of h raised to half. Think about it. I cannot differentiate h with respect to time. So I can differentiate h with respect to h. So what do? Simple. Just put dh by dt over here. Anyways, dh gets cancelled. This is nothing but chain rule, guys. Cool? Okay, so this will become 2 root h, and then h raised to half's derivative will be, okay, think about it, half into h raised to minus half, okay, into dh by dt. Oh, that is interesting. What is this dh by dt? All right. So dh by dt is this thing. Is this thing out here. This thing out here. Rate of change of this height is the velocity of this surface. the rate at which that surface falls down. Let's say I call that as U. Let's say I call this as V. Can't I use equation of continuity over here and say U, okay, into that area which is A naught, okay, that area which is A naught will be equal to small v into small a, or whatever, that capital A out here, okay. So that's what it will be. Equation of continuity, U into velocity will be this velocity into area, okay. Now think about it, this U will be this V A by A naught, but this A by A naught, I know what the value is, fraction. A by A naught, 5 by 500, it's nothing but 1 by 100. It's nothing but 1 by 100. Cool. Now carefully start substituting things. Carefully start substituting things, because what we want is dH by dt, and this dH by dt is nothing but U. This is rate of change of height, dH, rate of change of height, dH by dt. That's it. Use it over here as it is. So you will get this as V divided by 100. This is V divided by 100. I hope this is clear. And what is this dx by dt? This dx by dt is the velocity which you want to find over here. So that is the velocity in the x direction which you want to find. Okay, now things have become very simple. So let's try and solve this. So this Vx therefore will be 2 goes, root of h has come down, so it will become root of h divided by small h, and that 100 is also there below, and this V, do not forget, this V is nothing but bitorsally root of 2g this height which is small h. So just substitute root of 2g small h, and now you know what will get cancelled, this small h and this small h. So only these terms are remaining. So just see what will it give you. So root of 2 into g, which is 10, into height h 5 divided by 100. 2 5s are 10, 10 into 10 100, 100's root is also 10. So 10 divided by 100, which is 0.1 meters per second. That is the answer. I hope this is clear. Isn't it a beautiful problem, guys? Isn't it a beautiful problem? So many concepts are involved, and I hope you are seeing that this is what KVPY asks. Divyansh, why don't you ping me on Instagram? I'll definitely help you. Or put a comment after the video. I'll definitely answer that query. Okay? Cool. Divyansh, don't worry. I'll help you out. Okay? Let's just solve the problems right now. Cool. 0.1 meters per second. Last question for today. And by the way, let me tell you, many websites have also given a wrong answer for this question. See, it's very important. Why I keep mentioning, all these things is because a lot of people unnecessarily waste their time downloading stuff from the internet, and then they realize later on that all these concepts are wrong. Understand, there is a lot of material online, but you do not know what is correct, what is wrong. You might learn the wrong concept, and nobody will tell you this is wrong unless and until you actually lose marks in the exam, and you'll be like, oh, I thought this was like this. So it's very important that you actually follow proper trusted sources, and better is you follow proper reputed YouTube channels like ours over here, and any channel on Vedantu for that matter. And obviously there are other channels as well, but understand that's one thing on YouTube, and number two, on Vedantu or any such coaching, all right, understand we give you proper material. There is no fake stuff, there is no wrong answers, and even if something is wrong, the teacher will tell you, listen, this is wrong, or this is how it has to be solved. That's very important. Okay, cool. Now let's solve this question. Very interesting question, and the method to solve this is, there is a bubble which is expanding, okay, uniformly at speed v, and water is incompressible. The question is, find the kinetic energy of the water being pushed. Okay, so let's try this out. So what we need to do over here is, imagine this is that bubble of radius r, and it is expanding with velocity v. Okay, now just imagine a hypothetical surface Okay, just imagine a hypothetical surface. This bubble has air inside. There is water everywhere. This green line is a hypothetical surface at a distance x from the center. So the radius is x and the thickness is dx. That dx, the thin surface, spherical surface, will have dm mass of water. Think about it. That will have dm mass of water. Isn't that correct? Now think about it. If the bubble expands, it will push the water everywhere. It's going to push the water everywhere. And if it's going to push the water everywhere, every point will have some velocity, including this green surface. This might have some velocity v. Now, I want you to visualize this. If the inner bubble expands and it is pushing with velocity v, as you go away and away, the effective area increases. The speed at which the water moves out will also change. Equation of continuity. The water is going out, it's flowing everywhere outside like this because the bubble is expanding. But since the effective area is increasing, the velocity should drop down. Did you guys get it? Okay, think Ankit like this. There is a bubble in water, it is expanding. What will happen? It will push the water. It will push the water everywhere, right? So the water which is very close will have the same speed v. But water which is little bit far away, it will have less speed. Why will it have less speed? Because visualize the streamlines. There will be like spikes everywhere. And that streamlines will have an effective area which is larger than the original area. So that's why area increases, speed decreases. I hope this is clear. Is that clear, everyone? Okay, very interesting concept. So first thing, let's call this as Vx, and by equation of continuity, I can say the area here into this surface's velocity, which is 4 pi, what is that radius? R square, into that velocity should be equal to this area into this velocity, which is 4 pi x square into Vx. Okay, let's cancel 4 pi and I'll get Vx is R square by x square into V. Great, everybody has understood this point. Now think about it. What will be the kinetic energy of the mass which is present in that shell whose mass is dm? It will be dk, and that dk is very small kinetic energy of all the particles in that small shell, dm mass. So it will be half dm. Remember, all the particles are moving with velocity vx everywhere outside. So it will be half dm vx square. Think about it. Half dm vx square. See, I'll make you visualize. It's something like this. The particles are going to move this way everywhere outside. As you go away, the speed is going to reduce. As you go away, the speed is going to reduce. That's what has happened. And more away, the speed is going to be even less because the effective area is decreased. This is how the water is moving. Now you have to find the total kinetic energy of the water. So each shell will have some kinetic energy. Dk. And there are how many shells like that? Infinite shells. So I have to sum up all their kinetic energies. That means integration. That's what is required. Each shell's kinetic energy is half dm vx square. And what is dm? dm is density into volume of that shell. And vx square is nothing but r square by x square v whole square. I just substituted it from the top. Cool. Now the next point is, what is the volume of that shell? That volume of the thin shell, the thickness, will be how much area it has. Think about it. It will have some area into the thickness itself. So it is 4 pi x square is the surface area. Think about it. That green surface will have surface area 4 pi x square and thickness is dx. So area into thickness will give me that volume present in that green part. So it will be into dx, and this will become r raised to 4 v square by x raised to 4. Now I'll erase this part, it's not required, I believe. Okay, now just cancel out few things and let's see what is dk. Dk is that will become 2 pi. So 2 will cancel out, pi is there, rho is there, and I have also r raised to 4, and I also have v square, and x square gets cancelled, and dx remains on the top and x square remains below. That's what I'll get dk as. Okay, now think about it. What will be the total kinetic energy? It will be the integration of all this. So it will be 2 pi rho r raised to 4 v square integration of dx, or rather x raised to minus 2 dx. Now what will be the limits of integration? From r till infinity. I have to take all those shells from r to infinity. So guys, this will become 2 pi rho r raised to 4 v square. X raised to minus 2 is integral. X raised to minus 1 by minus 1. So it will become x raised to minus 1 by minus 1 from r to infinity. This will be nothing but, think about it, what will it be? First put infinity. So it will be minus 1 by infinity minus 1 by r. This is what it will expand. First put infinity in x and then put r as x. Okay? Sorry, you put x as r. Yeah, my bad. Okay, so you substitute infinity and then you substitute r and subtract the 2. And 1 by infinity, guys, what is 1 by infinity? 0. Minus minus plus, so it will become 1 by r. That's it. So this term has become 1 by r. So it will become 2 pi rho r raised to 4 v square into 1 by r. R goes and you will get 2 pi rho r cube v square. That is the final answer. That is the final answer. Yes, correct. I hope this is clear. What a good question this is. And check the answer. Yes, it is 2 pi rho r cube v square. Have you guys enjoyed the session? Now I'll tell you which questions I have done today in the class. I have only done the toughest questions. I only did the toughest questions because VK, what did I not answer? Please let me know. I'll definitely answer to any of your questions. Yes. So guys, the easy ones I have kept it as homework. And believe me, the easy ones are plenty in number. So don't get scared. There are few hard ones which I solved today, or conceptual ones or lengthy ones, and the remaining ones are easy. And best part, I have kept the solutions for these questions in the slides, in the PDF which is there in the description box. Not only the answer but also the solution properly with diagrams, whatever is needed, everything, all the explanations for all the questions has been mentioned. And you will see that the questions are very, very easy. I want you guys to read through the solution because this is a complete paper discussion out here for the mock test. All the solutions have been mentioned and you'll realize, oh, this paper is actually simple. And you will get to know a lot of things which will help you in the actual KVPY examination. Okay, so guys, I hope you will go through all these things and also consider the crash course which starts. There is a separate crash course for JEE plus mains and just a JEE crash course. Both are there and both have part test series, live discussions, doubt solving, etc. So if you just take the crash course, it is 8,000 rupees after discount when you use the coupon code SHCC21. If you take the crash course plus CBSE crash course, it's 9,600 rupees. 1,600 extra, you get the CBSE material also. So go check the description box. All the details have been mentioned. The coupon code is the same. Same thing will be there in both the things. Only thing extra in the CBSE crash course will be the CBSE stuff and CBSE test series. Go check out our Telegram group for all the official updates. Don't join any other group. I hope that is understood. I hope this is very, very clear. Cool. Yeah. And I hope you have enjoyed today's class, and I hope you have already hit the subscribe button if you're a new user, and I hope you have already hit the like button if you have enjoyed today's explanation. So guys, yes, jumping off moving train should not be tried at home. Oh yeah, I should have probably cancelled out that do not try it out at home. Okay, chalo, I'll see you guys on Monday. Monday, very special session. All 11th standard formulas revision in one shot. All complete 11th standard formulas. So do not forget to attend that session. 7 o'clock Monday, and many more sessions coming up next week. Bye bye. Take care. This was Shreyas here, your master teacher for physics at Vedantu.